Hello guys, this is CodeNCode and this is the 8th lecture of this dynamic programming series part 1. And in this lecture we are going to study about subset sum problem from dynamic programming. And this is part 1 because there is another lecture for the same problem subset sum with different properties. So the problem is we are given an array with n elements and also a number m, and we have to test whether there exists a subset of the array such that the sum of its element is equals to m. So for the first problem, we have to test whether there exists a subarray or subset such not subarray but subset such that its sum of its element is equals to 12. So we see 5, 3 and 4 sum up to 12, so we would return true. For the second problem, the array is 2, 5 and 3 and the sum we want is 9. So as you can see, in total there would be 2 to the power 3, which is in total 8 different subsets, but none of the subset would be equal to 9. So we would return false. So this is the problem. We have to return true or false based on the fact that there exists a subset such that the sum of its element is equals to m or not. So there are two different approaches using DP. Both of them, I'm not counting recursive one here, I'm only talking about iterative ones. There are two different iterative approach. First, with time complexity n cross m, where n are the number of elements in the array and m is the total sum, and the space complexity also of this approach is n cross m. While the second approach also takes n cross m time, but the space complexity is not n cross m but only m, where m is the total sum. So in this lecture we would study about the first technique, in which the space and time complexity are n cross m. So to solve this problem, we would take a DP array, a 2D DP array with n plus 1 number of rows and m plus 1 number of columns, so that we have indices from 0 to n and also 0 to m, where DP of ij would be true or false depending on the fact that whether there exists a subset such that its sum is equals to j using first I elements. So I can range from 0 to n. 0 means we are using no elements and n means we are using complete elements. So our DP of ij would be true if we can make the total sum j using first I elements. Otherwise it would be false. It would be more clear when we take example. So for the same problem where m is equals to 12 and n is equals to 4, I've taken a DP array of size 5 cross 13, so that I have indices from 0 to 4 and 0 to 12. So each cell would be either true or false. So this is a Boolean array. So cell 2, 4 would be true if using first two values you are able to create some you are able to make some 4. But as we can see, since we have only access to first two elements, that is 2 and 5, there is no way you can make total sum 4. So of course 2, 4 would be false. So when you start solving a problem using iterative approach, first thing you do is initialize the array. So this, as you can see, zeroth row means we have access to no elements, or basically current set is empty. So this is what we are starting with. So if I have an empty set, can I make a sum 0? Of course, that is why 0, 0 would be filled with true or 1. 1 would indicate true and 0 would indicate false. Now using this empty set, can you make some 1, 2, 3 or up to 12 any number which is positive? The answer is no. If I only have an empty set, only thing I can create is sum 0. I can't create anything which is positive. That is why for the rest of the cells, when we have access to 0 elements of the array, would be 0, which means false. Which means if you have access to no element from the array, if you are using first 0 elements from the array, then you can't make any positive sum. That is why the rest are filled with 0. Now for the first row means we now have access to, we can use elements up to first index. Indexing in this case start from 1. So this is at index 1, 2, 3 and 4. So now we have access to index 1 elements up to index 1. So up to index 1 there is only one element, that is 2. So now we have access to 2. So can you make some 0? If you are going to use 2, of course the sum that you want to create or make should be at least 2, right? So you can't use 2 to make some 0. That doesn't make any sense, because 2 is of course greater than 0. So for 0 and 1 we would just copy the values from above, and in fact for this whole row these two values are copied from above, while these I have generated. And I'm not going to explain this one because things won't be that much clear. I will be explaining from row 2. That would make things clear, and once you have understood the thing how the rows are filled, you would be able to understand how row 1 was filled. So I'm not going to explain row 1 because that won't make things clear. So I would start from second row. So now I is equals to 2, which means now we have access to first 2 elements of the array. Now our current set would be 2 and 5, because now we have access to first 2 elements. Now and we would make decision for this second element only. So since second element is 5, can you use 5 to make some 4, 3, 2, 1 or 0? The answer is no. So in that case what we would do, till j is less than current element, which is 5, current index is, the row number is 2 and the element at index 2 is 5. So till j is less than 5, what we would do, we would simply copy the values from above. Why is that so? See, if you can make this sum, say 2, without using this element, that is using first one element, then of course if you have access to the second element, you can still make this. And the way to do is that simply ignore this element. How you were able to make 2? 1, 2 is true because using first element you can create some 2, of course, because 2 is able to make some 2. Now this would be also true for 2, 2, because if you are able to make any sum using first I rows, then you can make that sum using I plus 1 row as well. So that is why we would directly copy the values from above, because if I was able to make some 0 and 2 using only first value, then I'm also able to make these values using values up to 2 elements. So that is why sum 2 and 1 would be these two. In fact, from 0 to 4 we would copy all the values, because 4 is less than 5. Till 4 we would copy. Now we would go for the fifth element. Now to make sum 5, and since we are at row 2, so we have to make decision for second element, which is 5. So there are two things we can do with this element, this 5. First, either we can use it to make sum 5, or we can ignore it to make sum 5. If I ignore 5 to make sum 5, then if I ignore 5, which means I'm ignoring row 2. So if I'm ignoring row 2, can I make sum 5? The answer you can get is from row I minus 1. So again, same thing, if you are able to make total sum 5 using I minus 1 rows, then of course you can make sum 5 using I rows, right? So if you are able to make sum 5 using first 3 values, of course you can make 5 using 4 values. So that is why if I'm ignoring row 2, then I'll be directly looking at the I minus 1 jth cell, because I am currently ignoring row 2. So if I'm ignoring value 5, then I'll be looking at I minus 1 5. I minus 1 5 means using only one value, was I able to make sum 5 or not. So the answer is 0, which means I was not able to make sum 5 using one value. Of course the first value was 2, so you won't be able to make sum 5. So since I was not able to make sum 5, so by ignoring second element, that is 5, I won't be able to make sum 5. So I'm not getting any help from the above cell. Now the second thing is that suppose I want to include value 5 to make sum 5. In that case, if you are using 5, then you need you need to calculate the need which is the extra sum that you want. So sum that you want to create is 5, current element is 5, so the need would be sum minus current element. So sum is 5 minus current element is 5, so 5 minus 5 is 0, so you need 0 more, right? So if you are using this element, you need 0 sum more, because of course if there exists a sub array, a subset using first I minus 1 values such that their sum is equals to 0, then what you can do, you can take that subset, append 5 in that subset, and the total sum would be 5. One more time. If using first I minus 1 rows you were able to make sum 0, which means there was a subset using I minus 1 values whose value was 0, so you can take that subset, add 5 into that, and the total sum would be 5. So that is why we are calculating need. So need is current sum minus 5, which is 0. So using I minus 1 rows was I able to create some 0. So as you can see, I minus 1 0 is 1, which means using I minus 1 rows I was able to make some 0. So what we would do, we would go to I minus 1 at need was 0, so I minus 1 need. Since I minus 1 need is true, which means there exists a subset whose sum is 0. So in that subset you can append 5, the total sum would be 5. So at which indicates that we are able to make some 5. So that is why at position 5 we would insert true. So to make a sum, there are two ways. Either look directly above you. Looking directly above means you are currently ignoring this value, this element. Or what you can do, you can calculate need, which is current sum, which is j minus current element, which is 5. So j minus 5, that would be your need, and you would go to I minus 1 in the row I minus 1, and you would see whether your need was able to fulfill or not. If it was true, that means that sum exists, otherwise not. It would be more clear when we would solve for 6. So now since we have filled for 5, now we would go for 6. So you can create some 6 either by ignoring second row, which means ignoring 5. If you are ignoring 5, then you would look directly above. Directly above is false, so this is not helping us. Now we would calculate need is 6 minus 5, which is 1. So was I able to create some 1 using I minus 1 rows? Answer is false, and that is actually true, because if you only had element 2, you won't be able to make some 1. That is why it is false. So since we were not there doesn't exist any subset whose sum was 1, then you won't be able to make some 6 using element 5. So here we would have to fill 0, because if you want to use 5, then there must exist a subset using I minus 1 rows such that its sum was 1 if you wanted to make total sum 6. So since we see that I minus 1 1, that is 1 1 is false, that is why we won't be able to make some 6 using this element. Now we will move on to 7. Now same thing, since upper one is not helping us, so we would calculate need is 2. So we would go I minus 1 2, which is this 1 2. 1 2 is true, because if we only had access to 2, we were able to make total sum 2. So that is why 1 2 is true. So since we were able to make some 2, we are able to make some 7. How? All we can do, we can take that subset which was able to make some 2, and in that subset you can directly append 5, so the total sum would become 7. So if you were able to make some 2, you are able to make some 7. Now for 8 we would calculate, since upper one is not helping, you would calculate need, which is 3, since you were not able to make 3. So here you would insert false, and the rest of it would be false for the rest of the elements as well, because you won't be able to make 4 5 6 and 7. As you can see, 4 5 6 and 7, every sum is false in I minus 1th row. That is why you would be getting false here. Now then I would increment, I would be 3, and element at index or position 3 is 3. So from 0 to 2 we would directly copy the values from above row. Now we would try to make some 0. For that, since above one is not helping, which means using first 2 elements we were not able to make some 3. Of course, using first 2 elements, that is 2 and 5, you won't be able to make some 3. So this is not helping us, so we would try to make some 3 using element 3. So we would calculate need, which is 0. So were we able to make some 0 using I minus 1 rows? Of course we were able to make some 0. That is why we would fill here 1, and same way we would fill for the rest of the values. For this is 1 because 5 above 1 is 1, so this would be 1. Why? Because using first two values I minus 1 rows, which means using first two values we were able to make some 5. So even if I ignore this element, I am still able to make some 5. How? Just ignore 3 and you will be you see there exists an element whose sum is equals to 5, or more strictly, there exists a subset whose sum is equals to 5. That is why even if I ignore the third element, I am still able to make some 5. So will we be able to make some 6? For that, since upper one is not helping, you will go for need is 3. Since I minus 1 3 is 0, so you won't be able to make some 6. For 7 we would be able to make some, because the upper one is 1, so we would directly copy. We are able to make some 8 because even though upper one is not helping, need is 5, because 8 minus 3 is 5, and I minus 1 5 is true, which means using first two values you are able to make a subset sum 5. In that subset you can append 3, so the total sum would be 8. Using the same approach, we can fill the complete DP table, and this would be our answer. Using first 4 values or using n values, are we able to make some 12? The answer is yes. As a last in the DP nm we are having true, and we are able to make some 12. So this would be our answer. So if DP of nm is equals to true, we would return true, otherwise false. Now since you have you know that how the DP table is filled, you can yourself figure out how I filled the first row. And second one important thing is that once in a cell you find 1, then starting from that cell all the way down you would always have ones. Reason, if you can make some 7 using only first two values, of course you can make some 7 even if you add more values, because you can simply ignore those values and there still exists a subset whose value whose sum is equals to 7. That is why once you get in any cell 1, then all the way starting from that cell down to the last row, everything would be 1. So this is how we solve this problem, and if I show you the code, it would be something like this. Let's take array, currently no more than these elements. We need n and m. I hope this is visible to you guys. This should be more clear. Yeah, so now n m now we are taking the input array. After that we would take a DP array of size n plus 1 m plus 1 and initialize all the values. In fact, we don't have to initialize all the values. What we can do, we don't have to take it, we can take bool or int, doesn't matter. 0 1 is what it indicates, the two conditions. So of initialization phase, as already explained, 0 0 we have to fill with 1, the rest would be 0. So DP of 0 0 is equals to 1. For the rest of the value from 1 to m, you can fill DP of 0i as 0. Now we would start from row 1 to row 4. So we would start from row 1, we'll go all the way till n, and for each j started from 0 to m, we would fill each cell ij. What we do first, we copy the value from the upper cell till j is smaller than ai. So when we are going to fill for the second row, what we would do, we would copy all the values from above cell till 4, till j is equals to 4. So if j is smaller than current element, what we would do, we would directly copy dp of ij is equals to dp of I minus 1j. We would directly copy from the above cell. Else what we do, else we calculate need is equals to j minus ar of I. So if dp of I minus 1 and j, which means I am looking at the direct above cell. So for this I am checking for I minus 1 j, that is the above cell. If the above cell is equals to 1 or dp of I minus 1 and need, if either the above cell is 1, or I minus 1 need is 1, in either, if either one of the condition is true, then dp of ij would be true, otherwise it would be false. So the final output would be, or final result or answer is equals to dp of n m. If answer is equals to true or 1, have I created it doesn't matter whether in C++ whether I fill values with 0, 1 or true or false. So that is why sometimes I write 1, sometimes 0, it doesn't matter. So if answer is true, we would say yes, else we would say no. So there's a problem. Yeah, I know. Just a second. Come on. Sorry. Okay. So n and m, 4 elements, 12 sum. Oh, come on. Oh, I think I haven't read the input. Yeah, I've taken n and m and not the input. Okay. Oh, sorry. I is less than equals to n and I'm running a loop from greater than equal to n. So 4 elements, 12 sum, 2, 5. What were the other values? 2, 5, 3 and 4. 2, 5, 3 and 4, and the answer is yes, as we can see. And let's try to make some other value, which is not possible. As you can see, we are using the first 3 values, we are not able to make some 9. So 3 elements, 2, 5, 3 and fish. Sorry. Just as you can see, using first 3 values we are not able to make some 9. So 3, 9, 2, 2, 5 and 3. So the answer is no. So this is how we proceed for the subset sum problem in dynamic programming. There is one more thing that you still need to take care, that is, what if someone asks what are the values using which the total sum is equals to 12. So the values are 5, 3 and 4. How you are going to print this? This is a homework for you. After, if the result is true or result is positive, then you also have to print the elements using which the total sum is going to be 12, or the element of that subset whose sum is equals to 12. You have to print that as well. So this is homework for you. If you are not able to solve that, that's completely okay, because I'm going to make video of that as well. So this was all for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.